Hey class, in this video I'm going to be talking about a couple new topics, persistent data and callbacks. These things are not necessarily related to each other, but as I was going through the different things that we can add to the game, these were kind of two of the big themes that came out. So I'll talk a bit about persistent data in the game. I'll also talk about callbacks as a way to do different actions in delayed state. So callbacks will be kind of a new concept with functions, but it's a good thing to cover, and we'll probably cover it in more detail at some point this semester. Persistent data is having data related to either the character or the scene in general that changes over the course of our experience, our game, our scene, whatever we want to call it. So this is a bit of a mishmash, but putting a few different things in here. So let's get started. I'm gonna open up to GitHub, and I'm on my MMP 310 repo. Make sure I'm up to date. And I think I said the last video that this would be the last time I duplicate the project, but I promised this one is the last time I'm going to duplicate the project. So I'm going to duplicate project 1-6, and I'm just going to call this one Snake Forest. So that'll be kind of the name of the game. So that way I'll really be like, this is my final version of this. One thing that I do want to do, I realize I have a lot of files, and I'm probably going to add some more files. Let's delete this thumbnail. So let's go ahead and make a couple folders to organize these a bit better. So I'm going to make a folder for images and a folder for classes. And so all the extra JavaScript files with our classes will go in here in the classes folder. So I'm just going to grab all those. You can skip this part if you want to just keep working with the kind of crazy folder, but I'm realizing it's starting to get a bit over crowded in here. So I'm going to put all the images in an images folder as well. I also have a new image that I created for a little item pickup. I'm going to add this extra life GIF, which is just like a little heart that I made. So I'm going to throw that in there as well. And so now I'm ready to get started. I'm going to grab MMP 310 and open it up in Sublime Text. And open up my index.html first. So I'm going to have to fix the source links here. So I just have to add classes in front of each one. Sketch.js is still in my main folder, so I'll just leave it where it is. And then on sketch.js, I'm going to have to update all of my images to go in the images folder. So I'm just going to add images, copy that, and just paste it in front of each one of these guys. So that should fix all of my files. So this is a little bit more of a sane organization. The classes has a bunch of different types of classes in there, so you could divide them even further if you want to, but I think this is good for now. So let's start talking about the idea of persistent data. So when we play our game now, I'm going to go ahead and open up the Sublime server. So I'm going to type in the URL here because I haven't finished this yet, and open up my console. Make sure I can see the whole scene here. So with our game as it is, nothing really changes depending on the order that I play things in. If I play one level versus another level, if I just walk around, there's not really a sense of progression. I can go back here and walk through and go really wherever I want to. And so one way that we can give more of a sense of progression to the game is to add some persistent data. So things that stay updated or are related to all the different scenes that we consistently keep track of. Some examples of some types of persistent data with a game is like the level. And so different games represent levels in different ways. Sometimes it's actual physical space. Sometimes it's like a level of achievement that the player gets to. Another type of persistent data we could have is a score. So the score is just like how many points the player has. Level and score can be kind of similar things, but they can also be different. And we can look at ways to differentiate those. Another thing that I'm going to add with the player is a sort of lives counter. So like a number of chances that the player gets before, they have to start over. And so that's very common, in Mario, you have like 3 lives. So we'll just do something like that. Depending on, how you want to go about it, there's a lot of different ways to implement these different types of persistent data. I'm going to do a very simple implementation where I'm not going to really change the game too much, but depending on what you're creating, you might want to do things differently. The main thing to remember is that these are all just numbers, right? Each one of these things is a number, and we can display it in different ways, but ultimately we're just keeping track of a number. So once we know what we want to keep track of, then the question becomes, where does this data belong? So we have our main program, which is the sketch.js. And we also have classes and scenes. We have our player. We also have individual scenes. So where does it make sense to put this data? The level is this like kind of top level thing. So you might think that should go in sketch.js. But the player is the one who's achieving the level. So you might think actually, that should go in the player. Same thing with the score. The score could be related to the game itself, or it could be related to the player. Lives, that sounds like something that belongs to the player. Ultimately, it doesn't really matter where this information goes as long as you understand where it goes and there's a good reason for it being there. So I'm going to do examples of both. So I'm going to have some global data. I'm going to have the level. So I'll start the level at 1. And I'm going to have the score. So I'll start the score at 0. Then inside of my player object, so I'll open up the player class. That's where I'll keep track of the lives. So besides everything else that's going on in here, I'll say player.lives or this.lives, and I'll start the player with 3 lives. If they lose 3 lives, then we'll have to reset the game. And so these things are persistent data because they are always present regardless of what scene we're on. One thing that we need to add when we have persistent data is a user interface or display. Right now, let's say, every time I jump over a snake, I'm adding to the score. The player would have no way of knowing that unless we told them in some way. So you could use a prompt to say, you got 10 points, but that would get pretty tedious if the player was constantly getting new prompts saying you got new points. So what's more common in a game or even an application is to have what's called a user interface, or sometimes it's called a heads-up display, but basically text on the screen or a combination of text and graphics that shows the metrics or the different stats or data that we're keeping track of. So that's what we'll do first. And we can think about where do we want to organize this. So we could just throw it directly in the draw function. The data is kind of like separate from any of our scenes. It's not part of our map scene. It's not part of our platform scenes. It's not part of our prompt scenes. It's kind of like always there. So we could just draw it directly in the draw function. But to keep our sort of object-oriented system going, we can make a new class where we can display the user information. So let's build that. So I'm going to make a new file, and I'm going to save this as inside of classes as display.js. And there's different things you could call this. Sometimes you could call this a user interface. I'm just calling it the display because we're not really going to interact with it. That would take a lot more time to sort of build out, buttons and different things. So I'm just going to call this the display. So the display class doesn't really have any of its own like persistent qualities. It basically just is going to draw text on the screen based on data from other parts of our program. So I'm just going to create a draw function here, and then we'll set up our display. So this is going to change my text stuff. So the text font, the text align, I'm going to want to change those things in the display. So I'm going to have to move these guys to to the functions that show text. So I think if I remember correctly, that's the portal. Yes, so I have some text here. So I'll move this in here. And then where else do we display text? In the prompt. So we'll put the original default text display that we had for the portal and the prompt from our main function, we'll put those inside those classes now because we are going to change these. So I'll just delete them from my sketch setup and I'll close these. And so with the display, I'm going to use a different font just so we know that it's, part of the display rather than something in the game. So for the text font, I'm going to use Andale Mono, which is like a sort of monospace font, kind of like the one that you see right here in my text editor. And then I'm just going to display these metrics that we created, the level, the score, and the player lives. So we'll start with the level. I'll just say text and use level as a label. And then if I want to add a number to that string, I just say plus level. And that's a global variable, so we can just reference it directly. And then I need a position. So I'm going to put this in the upper left corner. There's a lot of different places that you can put it. It doesn't really matter exactly where it goes, but you don't want it to be like taking up a ton of space probably. So I'll just do 10x and 20y. So let's test that. So to actually create the display, I'm going to have to add a display variable. So let's say variable display. And then inside of setup, I'll instantiate it. So I'll put this after the player. It doesn't really matter that much where it goes. So display equals new display. And then in my draw function, I'll just say display.draw. So you might be thinking that's a lot of work if I could just write this code in the draw function. And that's definitely, one perspective of coding, is that why would I create a variable and instantiate a class and say display.draw when I could have just written text font and text? And there is a good reason to think that. I could also make like a function display here and then just call display right here. I tend to make classes because who knows down the line as I build out this game what the display might turn into. I might have multiple different types of displays for different levels. I might want to draw the display in some scenes and not others. So there's a lot of reasons to think as you're developing a game, you might not want the display to just be a function or just be part of your main draw function. These decisions about code can be very controversial because people have, different opinions about how to do it. But ultimately, it kind of depends on who you're working with, what your preferences are, and what works best for you. Oh, and I forgot to attach my new class. So I'm going to put this down here because it's kind of related to like the prompt a little bit. There might be some similarity there, but okay. So now we see level 1 up there. It's pretty small. Let's make sure that the rest of my text still looks good. And so notice that what happens is the text, when it's first displayed, it doesn't have like a color or anything like that. And so when I go over this text, then it applies over here. So what we need to do is first reset the alignment. So I'm going to say text align is left center. So that way it won't be stuck over here. I'm going to make it a different color so it just stands out a little bit. So I'm going to say fill is yellow. And that's actually, even though I want it to be, kind of small, so it's not taking a lot of space, that is pretty small. So I'm going to also change the text size to like 20. Okay, so now we see the level. And now you can kind of design where you want your metrics to go. And you could even put like a background around it if you wanted to. I'm just going to leave the text there. Feel free to design this however you want. And you may have different metrics as well. So you don't necessarily have to have the same thing. So for the next one, I'm just going to put score. So score plus score. It's nice that these guys have the same number of characters. And then I'm just going to move this down a bit on the Y. Could also move it over on the X, but whatever you think looks good. So that looks pretty good. It's nice and small. It's pretty much out of the way. Another thing that you see a lot is that they'll use some kind of icon with a number instead of the text, so it takes up less space. But for now, I'm just going to leave that. And then for the lives, another way I can display this is instead of just showing, the label and a number, I could also use some sort of graphic. And for the lives, I'm just going to use a circle just to represent each life. So I'm going to say for let I equals 0. And then I is less than player.lives. So however many lives there are is how many circles I'll display. So that's one of the nice things with numbers. I can use a for loop and then just draw, a circle for each life. So I'm going to draw an ellipse. Let's make the fill red so it looks, it'll more likely correlate to what a player imagines a life it should look like. For the x value, I'm going to need to use I to figure that out. So let's say let x equals, let's start with 10. So it's the same position as the text, plus I times, let's say 20. So we'll move 20 pixels over each time. So let's try that. So that's x. And then for y, I'll move down another 20 pixels to 60. And then for the width, I'll try 10. That might be too small, but we can take a look at that. Had a typo there. Okay, so that's pretty good. I do want to move it over to the right a bit. You can see it's not quite lining up right here. So let's move this over to like 15. Okay, maybe even 20. Okay, 15 I think is good. And then I'm actually going to take off the stroke. I don't need that, so I'm going to say no stroke here. And I think that looks fine. I could increase the distance in between a little bit to match up with the rest of the UI if I wanted. So, you could play around with this and tweak it to get to where you want, but that's good enough for me. I can kind of see what's going on there. So those are my 3 pieces of persistent data. With a game, it might be interesting enough just to know what the score is, but we do want to use the data to change the way that the game works. Otherwise, there's no real point to having it. In the next part, I'll look at how can we combine these 3 different numbers to change the dynamic of the game. And that's going to, take place in each one of the scenes. So I have to identify the events that occur that trigger all these different parts. So just a really simple way of approaching this is I'm going to say I'm not allowed to go in here until I've beaten this level. And a really easy way to check for that is just using the level score as a check. So if I get in here, I'll increase my level by +1. And so that will allow me to access this new scene. So level has to be equal to 2. So that's one way I can do it. The next thing I'll do is I'll just have the score increase. And so whoever, finishes the game with the highest score, that, will just be its own merit. So the score will just increase when I'm inside of the platform style levels. And then another thing that I'll do is if I die inside the level, I'll lose a life. And if I lose all 3 of my lives, then I'll delete my score. So I'll be basically that essentially sets me back to the beginning of the game. So that's the basic premise that I'm going to go with for now. This is just kind of as an example. You can edit this or update this to do whatever you want. But just making a simple relationship between the 3 different pieces of data. So we have to look at where do these things happen. So to start, let's just add the score. That's going to be pretty simple. So I'm going to go to the platform scene. And what I want to do is basically just increase the player's score. And you could, do this in more or less complex ways. The easiest way to do this, right, is just as I'm playing the game, every time I don't die, I increase my score. So I just say score ++. And so the result of that will be that our score will change as we play the game. You can see when I'm in the map scene, the score isn't increasing because the platform scene isn't being drawn. But as soon as I join the platform scene, now we can see that score is going up as long as I'm, playing. And so now I've beaten that scene and I have a high score. And I can continue on to the next level. So that's pretty straightforward. You could increase the score by, different amounts. You could also tie the score to like specific amounts of progress, like getting past one of the obstacles. You may also want to have points at which the score, gets deleted. Like if I lose this scene, whatever makes the most sense to you is fine. For a quick example, if I wanted to tie the score to, for example, passing the objects, I can comment this out. And so here, we already have some code that tells us if the player's gotten past the obstacle. So we can use that. So we can say passes each obstacle and say if player.x is greater than obstacle.x, then score plus equals 10. The problem here that you'll see in a second is that with this system, this is just plain obstacle. So there are like little tricks that happen. So with this system, notice as soon as I cross one of the snakes, the score just keeps going up and up and up because I'm always going to be greater than whatever that snake was. So now what I have to do is actually keep track of how many snakes did I pass. So I would need another variable for that. So I could have something like this dot obstacles passed, and it starts at 0. And of course I would always have to reset that if I start the scene over, so I just put that in there. So you can see it starts to get a little bit more complicated as we start to have different things. So next I would have to say and I is greater than this dot obstacles passed. And so then if I say this dot obstacles passed plus plus. So that way I keep track of how many obstacles I've gone past. And actually I can say greater than or equal to here, I think. So let's see if that works. Okay, so that seems to have worked. As I pass each obstacle, I get points. Now my score is 50. If I play again, now I'm getting points again. So another thing that you might want to fix is how do I prevent the player from getting points for playing the same level over and over again? So there's another variable that we could introduce, like did the player win? So we could say this dot player won, or yeah, that's fine. So that's going to be false. But if the player wins, so down here, remember this is when the player gets past last obstacle. So now, besides just changing the scene, we can say this dot player won equals true. And so the scene, each individual snake scene will keep track of whether or not the player beat that scene. And so now I can add another argument here, or another conditional here, this dot player won is not true. So that way the player can't get extra points for playing the same scene over and over again. And so there'll be kind of a finite number of points that the player can get in any playthrough. So let's see if that works. So now my score is 60. And if I go back to the beginning, so yeah, now I can replay the scene, which is fun, but I don't get any new score. So, it depends on what the functionality you would want is there. You might want the player to be able to rack up as many points as they want. And, my scene isn't very hard to win, so it doesn't really resemble any risk. Another thing I could do is say, if you already beat this once, we're going to increase the speed of the snakes to make it even harder to beat this time. So you can play with those dynamics to create, make the game more interesting if that's what your goal is. So that's good enough for the score. Let's stick with what we've got there. And so now what we want to do is increase the level when we beat the game or beat this particular scene. So that's when the player gets past the last obstacle, this dot player won. And so now we want to say that, the player beat this scene. I have another issue here. If I say level plus plus, just like I had the score plus plus earlier, so I just increase the level. If I go back in here, now I'm going to be able to increase my level as many times as I want by playing the same scene. So again, it depends on what you want the functionality to be. Maybe that's something that you think is good. Like I can just keep leveling up every time I play this same scene. If that's not what you want, then we have to prevent the player from doing that. And since we already actually created this player one value, we can just check it against that. So we can say if not this dot player one, just like we did up here. So if the player hasn't won yet, and actually we're going to want to put this before we set player to true, otherwise this isn't going to work. Then the level plus plus, and then we can also put player 1 equals true here. So basically we're saying this is when you win if you get past the last obstacle. If the player has not won this level yet, then level plus plus and this dot player 1 equals true. And then we go back to the win scene and then ultimately back to the map scene. Okay, so now I should be able to play this level and go to level 2. Got hit there. And now I'm on level 2. And if that worked, I shouldn't be able to get to level 3. And we'll reserve that for the next scene. So it just kind of depends on what your functionality is here. What I'm going with is just a linear progression. I beat one snake scene, I go to the next map. I beat another snake scene, I go to the final map. Okay, so we've got our level going up. We've got our score going up. Let's deal with our lives, which are obviously going to go the opposite way. So we do know when the player hits an obstacle right here. That's when they go to the lose scene. Okay, so let's also get rid of one of their lives. So we'll say player.lives minus equals 1, or minus minus if you prefer. That's pretty simple, but we're going to see there's a couple issues here. So if I lose, okay, you can see I lose a life. All right, so that's pretty obvious. We don't need to tell the player anymore. Okay, I lose again. Here's where we're going to run into a problem. I can just keep losing. It doesn't really matter how many lives the player has, right? So one thing we need to do is we need to come up with some type of consequence if you lose all of your lives. So this is where lives are getting lost. Let's go ahead and just put it right here. So let's say if player.lives equals 0, so if the player runs out of lives, then we're going to set the score back to 0. We're going to, instead of going to the lose scene, let's just go straight back to the map scene. Or actually, yeah, so what we can do is change scene, and instead of coming back to the scene, we're going to go back to the beginning. So I'll say beginning here, and then we'll put that other option in else. So normally it's going to change scenes and it's going to let you play over again, which is what the current scene does because we go to the lose scene. And then if you remember from our prompt, what we put into this next current scene is what we go back to after the prompt. So if you completely lose, we're going to send you back to the beginning scene. We actually need to reset your lives because if you completely lost and you're starting over, then we need to set lives back to 3. So this should be easy to test. I'm just going to go here and I'm just going to lose 1, 2, 3, and we go back to the beginning. So now we've got all of our metrics working together. So the next thing that we want to do is use one of those metrics to prevent going to the next scene until we've leveled up. Right now I'm at level 1 and I can just go to the next scene. Again, this is only if you want this functionality in your game. If you want the player to be able to go over where they want, then you don't need to worry about this. So now we kind of have to look at what is the mechanism through which the player gets to the next scene, and we're going to have to change a couple things around to make sure that this works correct. So there's 2 parts to going to the next scene. One is inside the map scene when the player enters the portal here. And there's also the portal scene itself, which actually just draws some information, but we are going to have a way of knowing if I'm allowed to go into this portal. And since we have multiple portals, we're going to have to add an extra attribute to keep track of that. And so let's also look at where the portal is created. So that's in the beginning scene. So when we make this portal to go into the forest, we're going to have to add some data in here that will let the portal keep track of whether or not you can go in there. So we're going to have to kind of work in between each one of these. So I'm going to go back to split view and put the portal over here. So let's start with the beginning. With our portal, we have the label of the portal or the message. Then we have the XY position, and then we have the scene that the portal takes us to. So let's add another argument. We're starting to get a lot of arguments here, but I think we're still in range where it's easy enough to make sense of what's going on. We'll just set a level that's required before we can enter the middle scene. So you start at level 1, so I'm just going to put this as level 2. So we're adding an argument here. And so in the portal, we're going to say level required. The nice thing about JavaScript is I can say this.level required equals level required. And even though I have a new argument here, and I don't really have like a level required for my snake portal, I can just ignore it there. So this will be undefined if there is no level required. And since we know that, we can use that to our advantage when we write our code. So I think that's good for the beginning scene. So now we have to think about how do we get that from the portal scene. That brings us back to the map scene. So I have let enter portal. And then if we collide with the player, we draw the text. And if the player hits enter, then enter portal goes to scene.to-open, and then we change the scene. And so instead of just immediately getting enter portal, what I'll do is I'll create a new function called request entrance. And since the portal knows what level is required, we can send that information back to the map scene. So I'll make a request entrance method here. We'll just say if there's no level required at all, so if this is undefined, then you can go in. So if no this.level required. So if it's the snake level with no level required, you can just immediately go in and that's fine. Or if the player's level, so if level, that's a global variable, is greater than or equal to this.level required. My font is a little too big for this. So if either of those things is true, I have the little or here. I could also just like use 2 if statements, but whatever. If either of those things is true, then we're going to return the scene to open. So return this dot scene to open. And so now I can replace this with, instead of scene to open, we're going to say request entrance. And that's going to send back the scene that we want to open if it's okay. And if not, then we'll just say else return false. If they're allowed to go in, we'll say this. If not, then we'll return false. So let's try that. So I'm level 1. If I walk over here and hit enter, okay, good. It doesn't let me go in. I'm going to cheat a second so I don't have to play the game to get to level 2. I'm just going to use my console to do it. And that worked. Awesome. Okay, so now we're level 2. So that's very good. So one thing I do have to do is I need to let the player know, like if I'm hitting enter and I'm not allowed in, that just seems like a bug. So we need to give them a different piece of text. We can just use the exact same logic here. So I can say if, this dot level required is undefined, or level is greater than or equal to this dot level required. So I'm using the same exact logic. Then we're going to say hit the enter key. So that way the snake portals will still work. And otherwise, then we're going to say you need only level, we need to know the level required. Only level plus this dot level required plus another string can enter. So I'm adding 3 strings here because it's kind of a long message. And then this is going to be the same XY. So I'm just going to copy and paste. Let me go here because this is getting long. So I'm just going to paste this in here. So same exact logic. If there's no level required, or this level, the current level number is greater than or equal to the required level for this portal, then we'll show the hit the enter key. Else we'll still show some text, but we'll explain to the player why they can't go in. So only level this dot level required can enter. So let's see if that works. So if I walk down here, yeah, so it says only level 2 can enter. And so if I just started playing the game, I'm like, well, how do I get level 2? Well, there's only one other thing to do here. And I should probably at this point use different graphics for these 2 different portals, but whatever. So I can fight the snakes and hopefully I can win. Okay, so I won. And so now I can enter the forest. Cool. One thing I noticed is that it doesn't really seem like I am doing the jump animation, does it? I'm just walking. So let's look at our player for a second. This is probably something I should have noticed before. Oh, here we go. So if is walking, so jumping should come first, I think. Yeah. So I think jumping should come first, because if I'm jumping, I'm definitely not walking. So walk goes down here, jump goes up here. So let's make sure that works. If I'm jumping, if I'm jumping and walking at the same time, then I still want to see the jump animation. And I had to set jump to be always true in this scene, so the character would always be jumping. Okay, so cool. Now I'm level 2, and now I can go in here. And so I have my next snake scene. This should make me level 3 without changing anything, because I haven't won this scene. My score is going up, and I won, so now I'm level 3. But if I go down here, I should be able to enter because I haven't added the level required yet. So that's the last thing that we need to do with this portion, is go to our middle scene and set the level required to the end scene to be 3. And so I think that's everything I need to do. Okay, so I'm just gonna play through real quick and make sure everything works. This is something I just am noticing now. I probably just ran out of time to do this in the last video. I'll do it real quick. You can skip this part if you don't care, but it's kind of bothering me how when I return to the map scenes, I'm not in the same place that I was, like it used to be in the function version of this program. So I'm gonna look at why that is. So with the map scene, there's no setup function for the map scene. Oh, but the setup is in these ones, and the player just gets to the same place. So I'm gonna implement something real quick. I already have an idea of how I wanna do this. In the map scene, I'm gonna have a global setup function here, or I'm gonna have a setup function in the main map scene rather than in the subclasses, like beginning, middle, and end. What I'm gonna do is say player.x equals this.playerx, player.y equals this.playerY. So what I'll do in the map scenes is I'll have like an original position. So instead of changing the player to the same position, I'm gonna save this as the original position for the map. So sorry, I'm going a bit fast here, but this is kind of off topic. Basically, in the beginning scene, I want the player to start in the middle, but if I go into one of the portals and come back, then I want them to stay wherever they were. So in my map scene, whenever I leave, so if I go into this portal, so if I enter portal that's here, then I want to set the this.playerx to the player x. So basically, when I leave this scene to go into the snake portal here, I'm going to save the current position of the player. So that way when I return, then I'll be save current position of player. So that way when I return here, I'll be in the position that I was before. So let me try that real quick. So when I beat this, great. So now I'm in the same position. Hopefully that'll stay true. One thing that I realized as soon as I finish that is if I lose a bunch of times, I should be back here. Let's open the platform scene and decide what to do here. This is like a game design decision that I don't want to spend a ton of time on. But basically, different games do this differently. Let's say you have, level 1, level 2, level 3. And you're playing along and you're doing good. You get through level 1, get through level 2, but then level 3, you die. Do you get set back to the beginning, or do you get set back to the beginning of level 3? What I'm going to do is set you back to the beginning because it's easier. So when I change scene, this is the platform scene. It's going to be the true in any scene. So it's always going to send you back to the beginning. And so then I'm just going to set scenes.beginning.playerx to width over 2. Scenes.beginning.playerY equals height over 2. Okay, so I'm pretending that I didn't completely brain fart on this earlier. So I need to delete the setup for my middle scene. So once I add in the setup for the map scene, because the middle scene extends map scene, if it has a setup function, that setup function overwrites the other setup function. So just like I did in my beginning scene down here, I just need to set these values as part of the constructor. So there is like a basic place for the player to go if they've never been in the scene yet, but it also allows it to keep track of the player's position as they move through the scene. So if they leave, they can come back. So we may want to make sure to put that in there. And then we also want to do that with the end scene. So with the end scene, again, I just want to take these guys out to save this as the initial position. So this dot player X. So initial scene position. And this dot player Y. Oh, I forgot to write equals. And so now I can delete that. You know, this isn't really super important, but whenever I notice stuff like that, I kind of want to fix it rather than just leave it hanging. And it is good to show all of the, like when you're building a really complex scene or game, all of the different little things that you have to keep account of. Okay, so now we can keep track of the score, keep track of the level, and we can also keep track of the players' lives.